Hi everybody, I'm Tony E at Show IP Interface Brief, and I'm here on the evening of day 6, and what a good day of labbing it's been. I labbed, I started this morning at about 10:30 in the morning, maybe sometime around there, and I labbed till about maybe 1:30 or 2. I had a little lunch, and then I was a family man until now, until after bedtime. So, great to be back. I'm looking forward to the next couple hours spending my time here labbing. So earlier today I was doing some thinking about what am I going to do with this 100 days of labbing and what's the point of all of it. So the point of all of it is for me to be accountable and to put forth a solid stride of 100 days labbing every day, focusing on different topic areas to prepare myself or to gauge my preparedness for the CCIE lab, which I'm looking to take at the end of the year. If I'm not ready at the end of the year, I'll move it. But if you've watched my first couple of videos, it's about drawing a line in the sand. And that line in the sand is the end of 2018 for me. And so that's all fine and dandy, but if it's just about labbing every day, then what's the point in making these videos? What's the point in putting in the extra effort? And if it's all for me, then there is no point. I could just do this myself and lab and be done. So I thought if these videos are going to sit around and live on YouTube, that they should be valuable. There should be some teachable moments in them. And so today when I was doing my lab, I thought, wow, it would be great if I could sort of explain this to somebody and kind of walk people through what I'm looking at on the screen. Now, I know I can show my screen to you guys, but actually what's going through my head when I'm looking at some of these topologies and things. Because maybe it will help other people. And maybe I'm wrong about something and someone can correct me and get me on the correct path. So all of this should be sort of teachable moments, and I want anyone who spends the time to watch one of these to walk away feeling like it has some value. Also, one of the best ways to I don't know what the exact quote is, but one of the best ways to learn something the most is to prepare yourself to teach it to somebody else. So in walking through a couple of things here as I lab and me trying to explain it and sort of document it in a video, it's helping me to also gauge my own understanding, and which might reveal some areas that maybe I'm not so clear on, and if that's the case, then great, because that's exactly what this experience is supposed to do. It's supposed to expose those weaknesses. It's not about just showing strength. It's about exposing weakness. So this is going to be, I think, the last day that I focus on DMVPN. This lab isn't any much different than my earlier DMVPN labs, but it has some other elements to consider, and that's why I thought this would be a great opportunity for me to try and teach this a little bit to help gauge my understanding and also to add some value to this. So this is going to be one of those live lab recordings. I'm going to just run through this entire lab. So the first 10 or 15 minutes, actually it's probably been a few minutes already, is going to be me probably doing some IP addressing. So if you don't want to see me just put in IP addresses, you could probably skip ahead 10 minutes. I'm starting a stopwatch now so I know how long I'm spending on this lab. And I got a little coffee, brought to you by the year Y2K. Okay, so let's take a look at the topology. If anyone watched my part 1 video, this topology will look very familiar. One of the major differences is this area. Previously, I had this as just one area. It was called 256, which is because it takes router 2, router 5, and router 6. That did not give me the results I was trying to see, or rather, it didn't give me the problem that I thought I was going to need to solve. And in order to do that, I needed to actually split that area in half. And so I did exactly that, and I created area 25 and area 26, and I got rid of the cloud that was in the middle. Other than that, everything else within the lab stayed the same. This is area 1, 2, 3, 4 because we have router 1, router 2, routers 3 and 4. This is router 47 because this is, area 47 because of routers 4 and 7. So this is a perfect opportunity to sort of take a look at the topology, and in my mind and in your mind, you should already be thinking, what are the steps that need to happen in order to build this topology, and what are some trouble areas that we need to uncover. So what I notice here is there is no area 0 on the topology. And I'm not an OSPF expert, and so this isn't an OSPF deep dive. This is more of an exercise in going through OSPF area designs. So typically, let's see, if I clear this, open up a whiteboard. Typically in a lab drawing, you'll have a big area 0 in the middle, which is called your backbone area, and off of it will be your other areas. Right? Areas 1, 2, 3, and 4. Okay? And we'll give them a tail too. Area 5. Okay? And for OSPF, this is a router, this is a router, this is a router, this is a router. Right? OSPF puts interfaces in areas. Okay? And so that means at every border between two areas is a router. All of the areas need to touch area 0 in order to exchange routes, which means router 2 is going to advertise routes over into area 1, and area 1 is going to send them to the other areas. Okay, except for this little area, this little thing here, which we all learn in CCNA and CCNP class. This router right here will have no problem knowing area 4 and area 3's routes. But the rest of the topology, actually, area 3 will not learn router 4's routes, and neither will the rest of the topology. Router 4 is kind of by itself. And everyone learns in CCNA and CCNP that what you're going to need there is a virtual link. And that's to connect it to area 0. Okay, so anytime I'm looking at, where's the clear? Anytime I'm looking at a topology of routers, whatever they may be, this could be our area 0, this could be our area 1, and over here another router can be our area 2. I try to just disappear, or make the routers in my mind just sort of disappear. Right? And what that leaves you with is just normally a couple of remaining bubbles. But what you'll see here is no matter what areas you have, they're always connected to area 0 unless they're discontiguous and use a virtual link. So I'll do that over here as number 5. Virtual link. And what that means is if you take the routers away, which is your actual physical topology, the areas are always in a hub and spoke topology. At least that's the way I look at it. Everything always has to connect to area 0. Area 0 would be the hub, and everything else is just a spoke off of that. All the other areas in the entire topology, one way or another, are just a spoke off of area 0. That's how I envision it in my head. So if we go back to the topology, if everything is just a spoke off of area 0, where's area 0? The challenge here is not to try and get connectivity without area 0. There's not necessarily a hidden challenge here. I just want to be able to have full connectivity to all of my remote loopbacks. So every router has a loopback, which is a quad address of its router ID. So this is 1.1.1.1, and over here is 7.7.7.7, and so on. I want full reachability. That's all I was trying to do here. So again, where's area 0? Well, this is not area 0, right? So what if we just put area 0 here? Then we can build, I guess, a virtual link here this way. And I guess build a virtual link there that way. But I went a little different approach because I think that was the more obvious answer. So I wanted to try something else. My approach to this was going to be, let me go ahead and clear off the board. My approach to this was going to be, each one of these routers has a loopback address, which is the quad address of its router ID. So the way it looks right now, the loopback address is not in an area, which means router 4 will know how to get to this segment and will know how to get to this segment. But upstream and downstream, they will not know how to get to each other. Router 7 won't have any awareness of the upstream areas, and the OSPF area 1234 won't have any awareness of area 47 between routers 4 and 7. So I thought, what do we need to do to be able to get those to be treated like a hub and spoke? What if we take this loop back and we make it area 0? Now router 4 is in area 0. And after we do that, these guys should be able to exchange prefixes between them because there is a router in area 0. And that's all fine and dandy for this section of the topology. But what about the rest? Where do we put those areas? So I thought about it and I just said, you know what? We're going to need one here. So I'll use this loop back and put it in area 0, which will give me the same effect, right? Because without area 0, OSPF area 25 can never talk to OSPF area 26. Because they have to go through area 0, and there is no area 0 there. But as soon as I put that loop back in area 0, they can talk to each other. Maybe I think I'd have a green here. Green is for success. Okay, and since this is a DMVPN, DMVPN, I went ahead and put this guy in this loop back in area 0 as well. And I wanted to go ahead and do, I think I went with phase 2 here and phase 3 for DMVPN in this architecture. So we'll go through that. That's going to be my plan. That's my strategy. That's what I'm going with. And if there's time for anything else, we'll see what we can do about maybe some prefix filtering or something like that. But again, the focus here is not deep dive OSPF. The focus here is OSPF in a DMVPN architecture. And there are some things to consider there as well. Maybe I'll do another. I'm just thinking of a couple of good topics that would be good to cover, such as interface network types, or rather OSPF network types on interfaces in a DMVPN architecture and the gotchas with that. So let's clear off the screen and dive right in. I'm going to bring up a notepad so I can start typing some configs. The first couple of configs I want to type in, just get my environment set up. Like I said, you might want to skip ahead a couple of minutes past this point if you want to get straight to the meat of it. Let's see. Okay. I want to paste that. My router 1. Oh, and you know what? While I'm here, where's my notepad? I also want to go ahead and drop in a host name, which is in this case R1. I'll jump this around. Like I said, oh, look at all these terminals. I thought I had them open already. Router 2. Paste that in. Yeah, when I'm doing this by myself, I just run through it. I do realize that in doing studies for CCIE and just dedicating time to something in general, it can be sort of a mild waste of time going through IP addressing, which is why pre-built lab environments are so popular, because no one wants to sit and spend their time configuring IP addresses. You know, that's not what we're here to do. But when you're building labs the way I am, which is just raw, just some ideas that come to your head and you just want to try them, this is how you got to do it. Otherwise, I recommend going and getting a lab environment. The INE lab environment's really good. Narbix lab environment, if you guys take Narbix class, is really good. And I assume all other CCIE environments are really good as well. They'll just have experience with those. A couple of the Cisco 360 ones are popular as well. I really like those topologies. And generally, I think I messed up here. Generally, you don't spend much time IP addressing in those. The general connectivity is built, and you normally just have to go ahead and start configuring protocols or troubleshooting or sort of taking the next steps. Okay, so now I'm going to start my my NBMA addressing here, which is just going to be one common subnet just for easy reachability, and all of those are interface gigabit 00. Let's do IP address 172 17 100.1 will be fine. That's what I've been using for the past few labs. Come over here, no shut. And I know some people like to use secure CRT or some sort of, I'm a fan of multi-tab Putty myself. Super Putty is nice too. I just don't have that set up yet with my EVE-NG. I'm not one of those people who spends a lot of time sort of spit polishing their environment. It's a little raw, it's a little janky, and it gets the job done. And as long as it's not too much in the way, it'll be just fine. Okay, so that takes care of the NBMAs for that. I'm going to do this segment here between routers 4 and 7, and so that's going to be interface gigabit 01. IP address, I'm going to give it 172.17. I'll call it 47 and .4. And so this is 4. Paste that guy in. This is router 7. If you guys don't know, like, why do I have these terminal screens arranged this way instead of doing secure CRT with just the tabs at the top? First of all, the CCIE lab has been explained to me that they're individual Putty windows, and so I just kind of want to get used to Putty management. I think as CCIEs we are all experts in Putty management, or at least we have our bachelor's degrees in it. And I tend to arrange my console screens like the topology. For example, I got router 1 as the leftmost, so I have router 1 as the leftmost. And then here I have underneath router 1, I have router 2, router 3, and router 4. So this is 2, 3, and 4. And then underneath this right side of my screen, I have 5, 6, and 7. And so here on my terminals, I have 5, 6, and 7. I like to do that just so I kind of know where I am in the topology, and as well as the console screens. That's all. Okay, while I'm here on 7, I want to actually, while I'm here on 4, I can ping this side of the network and all of this side of the network. So let's go ahead and do that. It's probably not necessary, and I did this before, but I like trying to use the TCL scripts just because I want to keep that fresh in my mind. And we can do all the addresses here, which is 17.100.1, 172.2.3, and our self.4, and then we can do 172.16.47.4, which is our self, and 172.17. I just realized that one I just did is incorrect. It's okay. All right, I'm going to leave it. I don't think it will have an effect on us. Address, I'm going to do a repeat count of 3 and hit it. Okay, that's router 1 I can reach, router 2 I can reach, router 3. That's the one I messed up the IP address. It looks like I got a duplicate address. Something is going on here. Looks like router 7 might have a duplicate address. Do show IP interface brief. And it does. So let's do IP address 172. Normally I use the keyboard shortcut Control-A to jump to the beginning of the line and Control-U to jump to the end of the line, but that's not working in these terminals and I can't figure out why. Okay. Good, I have reachability there. Now let's do the interfaces on router 2 and then router 5 and 6. So for that, it's going to be, I can just see the little 1 and the little 2 behind there. So let's do interface gigabit 0.0.1, IP address 172.1.7, and I'm going to do 25 because it's in between routers 2 and 5, and this is that 2. And do a 24-bit mask, no shut interface gigabit 2, IP address, and this is going to be between 2 and 6, and this is router 2. No shut. All right, and the interface is going to match on each side. So interface gigabit 0.1, IP address 172.17.25.5, and I'm going to do ping 172.172.25.2. All right, I got 5 bangs. Next one, interface gigabit 0.2. 726.6. This is 26.2. Looks like I'm not good there. Let's see what's going on. I gave myself the wrong IP address. I see it right here. I gave myself 171. And this is between routers 2 and 6, so 26.2. Let's go back here. Excellent. Okay, so we should have basic reachability through here. So I think my next steps are going to be building the DMVPN, which I'll do that largely in Notepad, as well as we'll do it with tunnel protection, because I want to get that hammered in. Then we'll introduce OSPF, and then we'll start mucking around in it. So let's bring up Notepad. Make a little division line there. Okay, first thing we want to do, Krypto ISACamp policy 1, our first policy, and again we're keeping it dirt simple. I want to do a pre-shared key. And then Krypto key, and we'll give it a wildcard address. Now let's do Krypto IPsec transform set. Make sure I spell it right. My trans. I always call them my trans. And then I've done this enough times to remember what I like to use. I'm going to exit this, and then I'm going to do Krypto IPsec profile DMVPN, and I'm going to do set trans, which is transform set my trans, and go with that. I think that, oh, and let me do an exit after that. And if I paste this in here on router 1 and it goes well, we'll slam it around the board. Okay, looks good. Let's bring up routers 2, 3, and 4. Here's 2. I just pasted it into router 6 and I didn't want to. It's not going to hurt there, but I should remove it. I was still in the TCL script, TCL shell. Okay, so to remove this, I always had a funny time removing these. I found I have to sort of do it in the reverse order that you entered it, because one thing depends on another. Okay, good. Okay, let's build those tunnels. So for anyone who is doing CCNA or CCNP, DMVPN is probably in the CCNA. I don't actually know if it is or not, but the CCNA is including some stuff that wasn't in it when I took it. I only took it 4.5 years ago. So when I first saw my first DMVPN configuration, I was just looking at this long list of configs and just thinking like, wow, I have no clue what any of this actually does. And it wasn't until I've done it over and over and over and over, and I'm able to break it out into smaller pieces, that I know what these things are. So I'm going to try and explain a little bit of that here, again, because I want to make these videos have some real value, not just me running through them. Okay, so I'm going to begin by creating our tunnel interface. I'm going to give it an IP address. I always like this schema. I don't know why. It's just easy for me to type. And they all need to share a subnet. That's the first chunk. Now your hub configuration is going to be slightly different from your spoke configuration with regard to the mappings and the next hop server configuration. Okay, and that's going to be here. So let's set up IP NHRP map multicast dynamic, which just means that I will map my multicast destinations to destinations I've learned dynamically. This is the hub's configuration. That's all you need for that. The spokes won't have this. They'll have a different set of configs there. And they don't need a next hop, excuse me, this hub does not need a next hop server because it is the next hop server in a single hub architecture. Okay, we also need to define a network ID, IP NHRP network ID, and 1, 2, 3, 4 for our 4 routers. Okay, That's it. So you see I'm putting some space in between here. Next is our tunnel configs. Now the tunnel configs are not part of DMVPN. This is really what makes DMVPN DMVPN. It's the next hop router protocol. Next hop resolution protocol. I was wondering, I was like, that next hop routing protocol doesn't sound right. Next hop resolution protocol. The tunnel configs that go here on the bottom are just your standard GRE tunnel configs. So that's why I put a little white space in between them. I do a couple of carriage returns so I can separate it in my mind. When we put all this together and it becomes one long string, it can just be too much. But if you separate it into these smaller chunks, like everyone knows how to create an interface and IP address. So you can just sort of put your finger over that part of the config. You know how to do that. Once you build a couple of GRE tunnels, if you haven't yet before, you'll know this part of the config. This is easy peasy stuff. I'm going to give it my source is a source interface and a tunnel mode, and we want this to be a GRE multipoint. And we don't set a tunnel destination when we're using the multipoint. If we're doing just GRE IP, we need to set a destination underneath it. Okay, and that's the hub configuration. Because the hub isn't going to have one single static destination. It's going to have many destinations, and that's why we don't define one there. For the spokes, same thing, interface tunnel 0. I'm going to go ahead and do router 2s, so I'll P it for router 2. So now I put a couple carriage returns in there because I don't need anything else. Then I'll start my next hop resolution protocols. IP and HRP. I want to map my multicast traffic to the NBMA address, the actual physical address, which is 172.17.101 for router 1. Next, I want to do IP NHRP, and I want to map my NHRP address, which is 10.123.234.1 of router 1, my next hop server, to the NBMA address, so 172.17.100.1. Next, I want to tell router 2 who your next hop server is. IP NHRP, next hop server, and we're going to use the NHRP address. That's it. These three lines is what makes up your DMVPN, essentially. Also a routing protocol, but this is the meat of the configs. And if you'll notice something here, there's a couple of ways to put this in depending on what version of iOS you're running. Some routers will let you put this in one line, which will allow you to map everything in one single config line. What you'll notice here is the NBMA address is here and here, and the NHRP address is here and here. You know, so in my mind, I'm sort of matching up these two things that are offset. And I know if I always do the map multicast first, next my map statement, NHRP and NBMA, and then finally my next hop server, I know they're always going to look like this and they should always match. And that's whether I'm doing IPv6 or IPv4, anything, they should always sort of have that pattern. And that's what I remember in my head. When I'm looking at this, I'm not remembering these commands specifically. I've done it enough times to remember them. But instead, what I'm doing is really trying to recognize the pattern of what it looks like. So it doesn't become a bunch of commands which are words in my mind. Instead, it becomes an image with a pattern inside of it. I don't know if that makes sense to anyone, but that's sort of how I approach a lot of the configurations throughout my career, throughout the certification experience, throughout working with Cisco and Juniper, everything. Everything sort of has, I remember it as an image with a specific pattern inside of it. And that's all I'm doing here. So I hope that was helpful. One of the reasons why I wanted to go over it. Okay, we finish off this config with the tunnel statements. Tunnel source, gigabit, I spelled source wrong. Tunnel source, gigabit 00. We want to do tunnel mode GRE multi because we want to do a phase 3, so we want each of our spokes not to only reach to router 1, but to have the ability to also form dynamic tunnels to the other spokes. So we define this as multi. And when you define it as multi, you do not need the tunnel destination and then whatever the destination would be. You don't need that when you define the multi. One thing I just looked up at the configs, and what I forgot here was next hop resolution protocol really won't turn itself on until you define a unique network ID. So it is common practice to make sure your network ID matches all the way across the topology, but it doesn't have to. It actually doesn't have to. It isn't passed across in the packet. But it's commonplace for them to match. Just like it's very common for you to make your sub interface match your encapsulation .1q, right? They don't actually have to match. In a router, I can make sub interface 100 and I can do encapsulation .1q 200. That's a valid configuration. There's no reason why they have to match, but it's commonplace to make them match. So let's go ahead and paste these suckers in. Router 1, where you at? Looks like I typed multicat. Okay, tunnel 0 is up. And let's grab this guy for router 2. Looks like, oh, I forgot 2 ends in tunnel. Actually, I'm just going to need to copy that bottom line for my router 2. Okay. So again, here's the beauty of DMVPN. All I do is change the IP address, go to the router, paste it in, and next. That's really awesome. I'm telling you what, guys, in preparing for the CCIE, I've been exposed to some additional technologies that I don't think I would have seen in my work every day, which is a lot of DMVPN is in CCIE lab studies and examples, as well as PFR. PFR is in the written exam, so I studied it a little bit. I haven't done very many labs with it. I've never seen it. Excuse me, I got hiccups. I've never seen it in the wild. But DMVPN with PFR, man, that's like, I mean, that's like I guess the basics. It's not really basic, but it's the basics of, what most SD-WAN companies, advertise. It's really cool to pair up those technologies and to build on top of them. I hope I get to do some of that. So if anyone's got any cool ideas or cool labs about that, send them my way. Definitely want to mess around with it. Okay, so from router 4, let's go ahead and do a ping test. I'm going to try to ping router 1. I wonder if I can ping router 2 from here. I can, and 3. Okay, so exit. Let's do some verification. I'm over here on router 4, which is the spokes, show IP, and HRP. Okay, awesome. Very cool. What's next? What's next for me? I think what I'm going to do is I'm going to go ahead and start, since DMVPN is done except for a routing protocol, I'm going to start right here between 4 and 7 and start introducing OSPF, and I'm going to crawl the network this way. I'm going to start from area 47, then go to our main area, and then I'm going to end on the area 25 and area 26. So let me pull up router 7. Here's something that I've experienced from doing a bunch of Cisco 360 labs, as well as in Narvix Bootcamp and INE examples as well. Sometimes for like mock lab requirements, it'll say you need to advertise all of your loopback addresses with their real mask. And so this was something I think we learned in CCNA. It was definitely drilled into us in CCNP. In order to do that on a loopback address, well, I guess we'll see. All right. Conf T, let's see, we have our do show IP interface brief. I want to make sure we have our interface here, so let's do interface loopback 0. IP OSPF 1, process of 1, and I'm going to go area 47. And I'm going to do interface gigabit 1, and do IP OSPF 1, area 47. So I'm bringing the loopback and the connected network into OSPF. So interface gigabit 1, IP OSPF 1, area 47. So do show IP OSPF interface brief. Just wanted to see here. I'm in a wait state, no neighbors. Just want to make sure I got the right interface. Process ID 1, area 47. I love using this command. Let's see, show IP OSPF neighbors. Should take a minute. It's got the neighbor ID. We're in a two-way state. There we go, from loading to full. I don't know if it's anything related to my environment. I doubt that it is, but what I've noticed is, let me show this. Show IP OSPF interface, and let me show our physical interface here, the one that we are forming an adjacency over to router 7. What I wanted to show you was the interface is network type broadcast, okay, and that's because this is an Ethernet segment, and even though it's just between two routers, Ethernet segments will default to broadcast type. And what I wanted to say was, I have noticed when you bring up OSPF neighbors on a broadcast network type broadcast segment, the neighbor adjacency takes longer to form. But if we were to do this over even an Ethernet segment, but if we do network type point to point, it comes up nearly immediately. I think that's because the broadcast is doing the DR/BDR election, and I don't remember what the timers are on that, but there are some timers there. Okay, so from router 4, show IP route OSPF, and we should be seeing our loopback here. So this loopback is being advertised as a /32, but I think this should be it is a /32. Well, I'll be damned. I'm going to change it to a /24, and sadly that means all of the loopbacks are wrong. Not wrong, but I wanted them all to be 24s. Okay. And I think here I'll do clear. I'm going to clear the process. Loading the full, show IP interface, show IP route OSPF. And here I still see my same prefix, but it's still advertised as a /32. And over here we can verify it is indeed a /24. And so one of the things I wanted to show was, a lot in my experience doing labs, one of the requirements is often advertise loopbacks with their real mask. So in order to do that, we need to go into interface loopback 0, and if we do show IP OSPF interface loopback 0, we can see the network type is loopback, and anytime there's network type loopback, it's going to advertise a host address, which is a /32. To change that, we want to do IP OSPF network type point to point. Now I just did an up arrow to refresh it on router 4, and see now I have a 24-bit mask. Okay, so our work there in that area for area 47 is done. Now let's go ahead and crawl around this way. So let's do let's start with our tunnel interface. I'm going to do conf t interface tunnel 0. I'm just thinking right now, do I want to show the common mistake and then show you how to fix it, or just show the straight right way? I guess I'll do the common mistake. IP OSPF 1, and I'm going to call this area 1234 because it's all of the routers there. And also, do show interface loopback 0. This has a 32-bit mask, so let's adjust that while we're here. Okay, show IP OSPF interface tunnel 0. What I wanted to show you is for tunnel 0, as soon as you turn on OSPF on a GRE tunnel interface, it defaults to network type point-to-point. We don't actually want point-to-point. It's going to cause our OSPF adjacencies to flap in a DMVPN architecture like this. There's a couple of ways to do this, and damn it, I should make another video about specifically OSPF network types and DMVPN. I got a nice chart I can make, or actually there's probably a nice chart made somewhere to show you guys. Anyhow, what we're going to do is we're going to set that to a point to multi-point network type, which means it won't elect a DR and a BDR, and it'll be exactly what we need. So let's do configure T, interface tunnel 0, or I tell you what, before I go any further, let me get over on router 1 and show you what we're doing here. Conf T, interface tunnel 0, IP OSPF, process 1, area 1234. From full to loading, that looks good. Okay. Now I think as soon as I introduce OSPF on router 3, things are going to go haywire. Yeah. Okay, so what's happening is the OSPF adjacencies from router 3 is trying to form an adjacency with router 1, and router 4 is trying to form an adjacency with router 1. But router 1 says, hey, wait a second, I'm a point-to-point. My tunnel interface is point-to-point, and I can only have one neighbor on this segment. But I see two neighbors on this segment, so it goes absolutely haywire. So what we're going to do is change this from IP OSPF network type point to multi-point, enter, and we're going to do the same all the way around. There we go. All right, let's do router 2 real quick. I mean, turning on OSPF on this DMVPN architecture is really just so simple. You've seen me do it 3 times already, but you go into the interface, the tunnel interface, do IP OSPF, your process, your area, and you turn it on. Be mindful of your network types. Okay. So all of these routers have formed an adjacency, and the routers in area 47 have formed an adjacency. If I go on router 4 and I do show IP route OSPF, I could see my remote loopback from router 7, as well as host routes for each of my NHRP addresses, the remote NHRP addresses on in the DMVPN tunnel, or the DMVPN network. So let's go on router 1. Router 1, show IP route OSPF. I can only see the host routes of the DMVPN cloud here. And again, that's because two non-backbone areas can't exchange routes between each other. They have to have a virtual link to area 0. So I thought this was kind of cool. Let me show IP OSPF interface loopback 0. Correct, it's not. Okay, show interface loopback 0. I'm trying to still avoid the doing the show run as often as I can. Okay, so how do we get area 47 and area 1, 2, 3, 4 to exchange routes between each other? What if I just come in here and interface loopback? Let me do IP OSPF. I want to do the network type point to point because I want it to be advertised as a with a 24-bit mask. It's real mask, not network type loopback. And then what if I do IP OSPF 1 area 0? Okay. You're not going to see any neighbors bounce, but we should see the remote networks here. You can see they're marked with an IA for inter-area routes, which means they come from another area. I always got inter-area and intra-area mixed up, so that's what I always say to remind myself. Inter means comes from another one, or an exchange between two separate things. So you see the connected link there and the remote loopback from router 7. So let's see if we can ping. We can. So we have full reachability. We want to do a trace. And we're going from router 1, we're going to 4 and to 7, right? Our only path there. Okay, perfect. Exactly what we wanted. Let's go ahead and router 3 and do show IP route OSPF. And again, we're seeing router 7's loopback, so we should have full reachability there. We'll ping test, and then if we do a trace, we're going to router 1 to router 4 to 7. Do it again. Router 1, router 4, router 7. Okay, so this is what I call the phase 2 DMVPN deployment for OSPF. I don't know if anyone's going to disagree with that, but I've seen throughout my studies over the past year the phases of DMVPN referenced differently, right? What they actually mean, which is phase 1, which is phase 2, which is phase 3. I think it's really confusing. So I always say like this: phase 1 is the spoke interfaces have tunnel destinations defined, which means all traffic must go from the spoke to the hub, no matter what the routing protocol says, because there is only one logical path. A phase 2, and typically in that, if that's the case, you simplify things by just advertising down a default route out to your spokes. Since they only have one path to come into the network, they don't need to know what all the specific subnets are. Reduces convergence time and everything. A phase 2 deployment is going to, each spoke is going to be aware of the networks on the other spokes, and as well as you can do, I think in EIGRP you do no IP or no next hop self, EIGRP, the autonomous system number, and that'll allow you to forward packets straight over. Now, phase 3, by my understanding, is when it's sort of routing protocol agnostic and is really built into next hop resolution protocol by setting redirects and shortcut. And that's exactly what we're going to do here in just a minute. All right, let's go on router 3. Let's modify our loopback, do that for router 2, and then I'm going to hop around, do 5 and 6. And 5 and 6 is just going to be standard areas. I'm not going to do NS stubs or not so stubby areas or anything like that. And for these two segments here, area 25 and 26, I'm going to set those segments as point-to-point. Or maybe I'll set one as point-to-point and one to the default, which is going to be broadcast for an Ethernet segment. Just to sort of test out that theory on the time it takes for the neighbors to form an adjacency. So I'm not going to configure the network type here. I'm just going to configure the area, and so it will default. Let me find out where's my 6 and my 5. They went dormant. Okay, so we'll do interface gigabit 0.1 and do IP OSPF 1. Excuse me, this is going to be a point-to-point, so IP OSPF network type. See, it comes right up. It was just like 2 or 3 seconds. Now if I come over here to router 6, and I'm not going to configure OSPF network type. Instead, I'm just going to do IP OSPF 1 area 26. We can just sit. Hey, that one came up right away. I don't know. Not the first time I've been wrong on a live video. Okay. Well, we're nearly complete here. Let's modify our masks for the loopbacks, their network types, and then let's start looking around and fishing out these other problems. So interface 0 IP address. Oh, and IP OSPF network type. I love doing point to point because it's just a roll of the fingers. Point to point is really nice. And I'm gonna go ahead and throw that in area 26. And interface loopback 0 IP OSPF network type. Here you go, point to point. And that's how you get it to advertise its mask. And just throw it in area 25. Okay, so let's check our interfaces. Show IP OSPF interface brief. Love that command. This gives us, uh-oh, looks like 5. I didn't change. Oh golly. Okay, run that command again. Show IP OSPF interface brief. Here we are. Here's our mask. Okay, both in area 25. Beautiful, beautiful. Okay, router 2. Let's check our neighbors. Show IP OSPF neighbors. Okay, from router 2's perspective, which is hiding here a little bit behind our right here, it has neighbor with router 1, router 5, and router 6. This is router 1, and then 5 and 6 are hiding behind the other wall of terminals there. Okay, all are in the full state. We're looking good to go. Remember 6 for the area 26 We did not change the network types, which it defaults to broadcast, and in a broadcast there is a DR/BDR election. And for our DMVPN interface, we did point to multipoint, and there is not a DR/BDR election, and there is not a DR/BDR election either on point-to-point interfaces, which is what our Area 25 is. Okay, so from Router 2's perspective, show IP route OSPF, let's see what you know. From Router 2's perspective, it knows Router 3's loopback, Router 4's loopback, 5, 6, and even Router 7, the big old remote Router 7. So let's do ping Router 7, and we're good to go there. Let's do a trace. And we go from Router 1 to 4 to 7. You guys can't see that, but I'm tracing it on the screen with my finger. Okay, that's great. Now let's hop over to Router 1 and see if Router 1 has learned anything from Area 25 and 26. And you see we're missing some loopbacks here if we were going to see them all. We're missing 2. I should have 2 in there. Why don't I have 2? Maybe I didn't include it. And that's exactly right. I didn't include it. I'm going to go ahead and fix the IP address. I'm sure it's messed up still. Oh, okay. So we're missing Router 2's loopback as well as 5 and 6's. So again, if we go back to the drawing board here, Router 2 can see all of the prefixes in Router 25 and all of the prefixes on Router 26, and is getting a good reference of all of the other prefixes throughout the network. And that's because Router 4 is acting as Area 0. So it's taking all of the prefixes from 47 and sending them into Area 1, 2, 3, 4 here. And Router 2 happens to be part of Area 1, 2, 3, 4. So it gets to know about everything within its own area and everything that Area 0 sends it. Router 2 also gets to know about these. However, because there is no Area 0 here, the rest of the network doesn't get to learn about anything in 25 or 26. So how do we fix that? Let's go ahead and take Router 2's loopback and put, I don't know what's going on there. Oh, because I'm leaning on the screen. Go ahead and put Router 2's loopback in Area 0. Okay, IP, I am here. Here I am on Router 2. IP OSPF 1, Area 0. Bang. As soon as I hit that, Router 6, Router 5. Let's go over to our very own Router 1. Let's see what you know, Router 1. And you see here the view in the routing table is drastically different. We now include Router 2's loopback, which is an inter-area route because Router 1 is in Area 1, 2, 3, 4. We're also learning 5 and 6's loopback now because those areas are now connected to Area 0. But what we have here, let me take another, what's going on here, my screen, take another look here. So what we did was This is area 0, and this is area 0. The problem we're going to have here is router 4 and router 2 are now acting as area 0, except they don't share the same information. Where's my router 4, router 2? Okay. I think what we're going to have here is dissimilar OSPF databases, which every router within an area should maintain the same database. So how I'm going to do that is I'm going to take router 1's loopback and put it in area 0, and then I'm going to form a virtual link between router 4 and router 1, and a virtual link between router 2 and router 1. So all 3 of these guys will be in area 0, and they should all maintain the same OSPF database. Let's see, I need that router open, okay, and also router 1. So just checking to see if I included it in already. I did not. So let's do, excuse me, interface loopback 0. Let's adjust the IP address. I don't know if I did that already. Network type point to point. IP OSPF 1. Call it area 0. Okay. Typically, I think in all the examples that I've seen in DMVPN architectures through example labs that use OSPF as the routing protocol, it's always the hub that is area 0, or the DMVPN cloud is area 0, which is your tunnel interfaces. And then any areas that are behind the spokes are standard areas or stub areas, whatever they may be. And which means all the traffic has to come up through the DMVPN. Here, I wanted to do something a little different, which is why I'm sort of experimenting with how this looks. Instead of trying to make all of the areas touch area 0, what I'm trying to do is put area 0 in between all of the areas by just activating a loopback and building a virtual link between them. Okay, so let's do show IP OSPF interface brief. Area 0, it's got a good mask. Okay. So to build a virtual link, that needs to happen in the router configuration. So let's do router OSPF 1. Let's do the target area we're going through, virtual link, and the router ID of the destination router, in which case it's going to be router 1. Let me come over here. Process ID 1, area 1234, virtual link, the router ID of our destination for the virtual link. Okay, for router 4, that's it. So let's go ahead and end that. For router 1, we need another one to go over to router 2. We need to build another virtual link going the other way. So I'll just put another command in here. Virtual link, and call that one 2222. Bang it in. router OSPF 1, area 1234, virtual link, and that's going to go to router 1. Loading to full. Alright, show IP OSPF. Okay, I have my virtual link and my loopback. Alright, the two virtual links here on router 1. One of them is going to router 2, the other is going to router 4, and router 4. Okay. This is not a deep dive into OSPF. This is not, and I'm not an OSPF expert yet. But we should now have similar databases. And just by my cursory look over, looks like we're looking at area 0, and we do in fact have similar databases. So my understanding of the OSPF database is that all the routers within an area need to have the same database, or else some janky things can happen. I don't know what all of those pitfalls are, but I look to uncover most of them as I start the OSPF section in my studies. So I thought this was pretty cool. Just another look at it, just to show you kind of what I did here one last time. Router 2 has a loopback, router 4 has a loopback, router 1 has a loopback. Each of those is in area 0, and I went ahead and connected those guys like this. So now router 25 and 26 touch area 0. Area 1, 2, 3, 4 touches area 0 in all of the places, and 47 touches area 0, which means now we can fully exchange routes all the way around, and the routers maintain the same databases. I don't know if this is a sort of best practice or if this is just some corner case. This was just sort of an idea that I had earlier, which was if you're given a topology without an area 0 and you have knowing that two non-backbone areas will not exchange link state updates with each other, how do you get around that? So that was the idea I had, and so I ran with it. So let's go ahead and do our sort of final reachability. I'm going to go router 7 to router 5. I guess I'll just start here at router 5. Let's go ping. Oh, and you know what? There is one other step I want to do. Source, loopback, 0. Okay, I can ping all the way. Let's do a trace. We're going to trace 7, and we're going to source from loopback 0. You can see it hops over to router 2, hops over to router 1, hops over to router 4, and then to 7, right? Our only path. Except this DMVPN cloud is still in phase 2. So we can cut out a hop out of that, introducing phase 3. Phase 3 is really simple to implement. Let me get the correct routers on the screen. Routers 1, routers 2, routers 3, and routers 4. Okay, router 1, there you are. Not what I wanted to do. Enable. We're nearly complete, guys. We're coming down to the end here. Okay. What we want to do is we want our NHRP to go ahead and send out some redirects. So let's do IP NHRP redirect, enter, And let's go ahead and on our spokes, let's do IP NHRP shortcut. Okay. Okay, so here I have router 5 in the top corner. If we run the trace again, I think we should still see the hop go through router 1, but if we run it a second time, we won't see it go through router 1, or we should not. Okay, same output as before. If I run it again, now I'm not hopping through router 1. It goes straight from 2 to 4 to 7. That means it's coming from router 5 to router 2, which is behind this console window, over here to router 4, and over. So it is taking the shortcut. And in fact, if we do show IP NHRP redirect, and we run this again, I think the redirect has already been sent. Where's my router 2? And on router 2, if I do show IP NHRP shortcut, here's the shortcut entry. And this was sent from router 1 to router 2 to say, hey, when you send I see that you're trying to reach the 7.7.7 prefix, there's a quicker way. You don't have to go through me. Even though I'm the hub, you can go straight to another spoke to get to that prefix. And that's exactly what this is outlining here. I just remembered that we didn't turn on tunnel protection. So let's go ahead and do that and hope that nothing breaks. Tunnel protection, IPsec, profile, DMVPN. I kind of want to do this quickly. I was trying to do it before OSPF could catch up and bounce. Let's try the trace again just to be sure. Okay, traffic is flowing, and so if we check our show Krypto. Cool.
I am who I say I am.
Okay. So, that's going to be a wrap for this video. I'm going to go ahead and close the recording down, produce the video, and then upload it in a little bit, and I'll probably continue labbing while that's working in the background. Like I said in the beginning, and I didn't mention this in the beginning, and now I feel like an a-hole for waiting till the end after an hour and 15 minutes later, which I think the video is actually a little longer than that. I'm going to make these topologies available. I know anyone can build them themselves. I'm also going to, I guess I could, I don't know how sharing topologies from EVE-NG actually works. I haven't shared a topology with anyone yet, so I'm going to go ahead and get a Dropbox account and start putting some of these labs in there, right? The 100 days of labbing that I wanted to do was really for me, but in order to make this valuable for anyone else, I want to be able to share those labs so you guys can run through it too if you want. So let me know if you want other topologies that I've done. I can dig them up. I'll try to organize this a bit better. All right, so that wraps it up. Thanks for sticking by. I got some music in this one, so I hope the music helps to break up the monotony of me just jabbering on. All right, guys. Thanks. See ya.